Hello, a Rosie math teacher coming at you from my 4th period accelerated grade 7 math class, where today we are answering several more items for our fast exam review from session 2. Today, though, I am only going to give a sprinkling of reminders rather than spoon feeding these children. So here we go in no particular order on today's item. This is number 37. What is the value of y? Here's your reminder. Listen quickly. You will need to use the following formula, s minus 2, to discover the number of triangles, multiplied by 180 degrees for not one, but 2 polygons. Now for the first polygon, let's look at the larger shape. That larger shape is what we call a regular polygon because all sides and all angles are, what's the big mathy word? Congruent. Excellent, guys. Meaning that blue angle equals all these angles are congruent. Now, when you do s minus 2, that means number of sides. So whatever the number of sides is, make sure you count them carefully. Put that number in place of sides, minus 2. Since that's the number of triangles it would create, you will multiply that by 180. Now, is it a regular polygon or an irregular polygon? It is regular. So if I wanted to find the individual angles, I would therefore divide this by number of sides. Now let me remind you, your online calculator, you can literally type into the online calculator x over y, and then in place of x, put number of sides minus 2 times 180 in the x position, numerator position, and then on the denominator position where the y was, you're going to place the number of sides. This will equal the number of angles for a single angle. Okay, in this case, we did them as blue angles, which I hope show up on my video there. I believe they do. Okay, now that I know those blue angles, I need to now use my formula for sides of a polygon in order to discover the missing angle y. All right, let me put my y there. This time, you want to find the angle sum, the sum of the interior angles for this smaller shape. Now, right away, tell me, regular or irregular? Irregular. So at no moment in time will I divide by number of sides. No. You simply want to ask yourself, first of all, you would use the formula. Again, number of sides, take away 2, multiply by 180. Please do not think this has the same number of sides as the earlier object. Count them carefully before you decide the number of sides. Do that number of sides, take away 2 times 180. Will that indeed give you the total number of degrees? Yes. But will all of the angles be congruent? No, because it was an irregular polygon. This time I'll make the angles red. Do you agree that these red angles I have just marked, you already know from your earlier computations? Yes. So you would have written down the number of those 2 congruent angles and then add 82 plus that, plus 100, plus y, all of those add-ins together equaling, what is the total number? Don't tell me it's what you would have gotten earlier when you did that new number of sides minus 2 times 180. Do you follow how I'm just giving you a sprinkling to remind you how to find it? Then solve for y, and you will have your answer. Do the best you can. Again, no particular order. This happens to be 36. Select yes or no to identify the solution or solutions to each equation. Now this time, guys, sometimes you'll have only one yes and the rest no's. Sometimes you'll have 2 yeses and the rest no's. So you have options. You can either whittle this down until you find the value of the a in a squared, or it is okay, if you do what a lot of you like to do, which is you substitute every single option in place of the A until you find out which ones will be yes and which ones will be no. You can solve it either way. But let me remind you, here's when it will have two possible options. I'm going to use examples that are not in here. Let's say, for example, that your value of A, when it was A squared, could equal 9. So would the square root of 9 potentially be 3? Yes or no? Yes, because 3 squared equals what? 9. What if they asked you, is there any other possible square root of 9? What is the one other possible square root of 9? It's still got a 3 in it. Okay, class. Negative 3 squared. Negative 3 times negative 3 will still be a what? Positive 9. So that's an example where you would say yes under 2 of the items. So if 3 were the potential value of A, and A squared was potentially equaling 9, you would say yes under both positive 3 as well as negative 3. Do you get what I'm trying to remind you of? Okay, that's my sprinkling for number 36. Now we're chatting about, again, no particular order. Number 34. Select the response that indicates the system of equations has, and this is where I have a half sheet of grid paper ready for each student to come and get a half sheet when they get to this item. I highly recommend you graph it to find no solution, one solution, or infinite number of solutions. I'll remind you, if when you graph your two equations, and you would do one system of equations on one graph, second system of equations on its own graph, third system of equations on its own graph. So you end up with 2 lines on each, right? Remember that when you are plotting, where does my plus 5 end up going on the what? Y-intercept. How do I find my second plotted point? I like to plug in place of x, the value of the denominator, and then plug into my calculator negative 2/3 times 3 plus 5. So my ordered pair would be 3 comma, whatever number my calculator gave me when I plugged all that in would be my new y value. Once I have made that second plotted point, would this equation now be a singular line? Yes. Do the same procedure with the second part of the system of equations. Now you will have 2 lines. If your 2 lines intersect with each other, the only solution they have in common is right where they intersect. So you would say that that would qualify as what? One solution only. Secondly, if you realized that your 2 lines are running parallel to each other, class, will these parallel lines ever intersect? No. If the answer is no, then this pattern would mean what? No solution. There's one final possibility. You could have a line that goes like this, and then you could have a line that goes right on top of it, meaning that at every single point along the way, it is laying on top of the other line. Therefore, you would call that what? Infinite number of solutions. That's it about question 34. For question 40, I want you during this to Google only this question. What is the formula for a 270 degrees clockwise rotation? Guys, before your FAST exam happens, you ought to memorize the following. Clockwise rotations, and you should memorize them for the following. For a 90 degree clockwise rotation, and remember, this is when they tell you something like x comma y will switch to, and then they give you another version like negative y comma x. You remember this? Okay? You would write them down and memorize for 3 things. 90 degrees clockwise, 180 degrees clockwise, 270, And what is the reason we don't need to write down for 360? Because it would come right back to exactly the same. So you don't need to memorize that. You would just have the same ordered pairs. Now, if we did 180 degrees clockwise, wouldn't it still be the same counterclockwise? If we're dealing with, let me do a beautiful, perfect circle here. If we're dealing with a circle, and each section is considered to be how many degrees? And this is a terrible perfect circle. Well, the circle's perfect, but hold on. I want my other line to be a little bit better there. Okay, you get the idea. If you understand that every single one of these angles is a 90-degree angle, do you see how a 90-degree clockwise is exactly the same as a 270-degree counterclockwise? Okay, so if they ask you 270-degree counterclockwise, which one of these would you use? 90-degree. If they ask you for a 90-degree counterclockwise, which one of these would you use? 270 degrees clockwise, because that gets you to the exact same point. So you do need to look those up. You do need to memorize them. For today, though, they just need you to use the 270 degrees clockwise rotation to change A, B, and C to their new ordered pairs. All right, at this time, those are all the sprinklings I'm going to do. Get busy, finish during class today.